Hi friends, welcome back to Edupedia world. Today we will be starting a fresh chapter which is current electricity, and our discussion today will be confined to three topics. First is current, we'll understand what is current. Then we'll move to potential, we'll understand the theory behind it and the units of potential. And finally we will see what is potential difference. And these understanding of these three are very important because this forms the basic skeleton and the foundation on which further discussions of electricity will be done. So let us see these important topics. Let us begin discussing about current. Current is defined as the rate of flow of charge. So the amount of charge flowing per unit time is called current. Current is denoted by I, and we know that the amount of charge is denoted by Q. Therefore, current I is charge Q upon time T, amount of charge passing per unit time. Okay. Now, device used to measure current is called ammeter. Ammeter. Let's discuss the units of current. The SI unit of current is called amperes. It's called ampere, denoted by an AMP, denoted by a capital A. We know that the unit of charge is coulomb and time is second. Therefore, an ampere is coulomb per second. Right. So 1 ampere is the amount of current passing through a system if a unit charge passes in 1 second. Right. So an ampere is the amount of current flowing when 1 coulomb charge passes in 1 second. Right. Now we have smaller units of ampere, namely milliampere, which is 10 to the power minus 3 ampere, and we have microampere, which is 10 to the power minus 6 ampere. So all these are units of current. Ampere is the SI unit of current. Next, let us see how does current flow. Okay, what happens is that in a metal is abundant of free electrons. So basically in a metal the free electrons move, and the movement of free electrons is equivalent to movement of charge, and as a result current flows through a metal wire. But in the case of electrolytes, electrons are not free to move. Rather, ions, that is positively charged ions called as cations and negatively charged ions called as anions, they move through the electrolyte, and the flow of the ions, positive and negative ions, result in flow of current since they are charged particles. Right. Now let us see, confine ourselves to the example of wire. Let's say we have a metallic wire, and let's say n electrons pass through a unit cross through a cross section in t second. Right. So what will be the current in this particular scenario? Now since there are n electrons, the total charge will be n times E. E is the charge of one electron. So Ne will be the total charge that flows in t seconds. But we know that the current is charge per unit time. So that can be reduced to Ne upon T. So if we know the number of electrons flowing through a cross section in a given time, we can find out how much current is flowing. Similar calculations can be done in the case of electrolytes too. Okay, now that we have a basic understanding of what is current, let us understand the concept of potential, and then we'll understand potential difference. So let's start with potential. As you might be knowing already that every object has a tendency to move from a position of higher potential energy to lower potential energy. That is the natural state. So higher potential energy to lower potential energy. Like suppose you have a ball, you are standing on the top of a high building and you release the ball, then the ball will come and land at the floor. So this is higher gravitational potential energy, this is lower gravitational potential energy. Therefore the ball moves from higher potential energy, in this case gravitational, to lower potential energy. Similarly, if we think about heat, right? If we think that we have a body at 70 degrees Celsius and attached to that there is another body at, let's say, 100 degrees Celsius. So here the potential for the bodies is the temperature of the body, and since this is at higher temperature, this is at lower temperature, the heat energy will flow from higher potential to lower potential, and this body, 100 degrees Celsius body, will lose heat, 70 degrees Celsius body will gain heat. So basically here too what we see is trying to minimize the potential. Fine. Now let's formally define what is potential in with respect to current electricity. So as we have seen in these cases that here heat flows, here the ball goes from higher region to lower region. Similarly, in the case of charged bodies, if they are joined by a metallic wire, then the charge moves in the direction determined by the quantity called electric potential of conductor, right? So suppose there is a charged body here and another charged body here, and if we join it by a metallic wire so that it can conduct, then the charge or current will move from, let's say this was at higher potential and this was at lower potential, then current will flow from higher potential to lower potential. Therefore the potential is that property, electrical property of the system which determines in what direction will the current flow, right? So current will flow from higher to lower potential. Now let us try to formalize this with example. Suppose this is positively charged, as I have shown here, this has positive charge. Okay, this has negative charge. So we can say that this is at high potential energy or high potential and this is at low potential. Therefore, as we have already shown here, that current will flow from high to low potential. But the catch here is that the charge carrier that is free to move are not positive charges. Rather, they are electrons which are negative charges. Right? So, though the current is moving from higher potential energy to lower potential energy, the electron, which is the charge carrier, will move in the opposite direction. So electrons flow from negative to positive, or from lower potential energy to higher potential energy. So this is an important thing that you need to keep in mind, that though things move from higher potential to lower potential, the electrons flow will be in the opposite direction because they are negatively charged, right? And this configuration you need to remember, because the direction of potential is defined based on the current, but the actual flow is by the electrons. Okay, so this should give you a rough idea about what the potential of the system manifests itself in for electrical system. Now let us define potential in terms of work done per unit charge. Okay, so potential at a point, potential at a point can be defined as the amount of work required, amount of work done in bringing a unit charge, positive charge, from infinity to that point. Okay, so let us see what it's saying. Potential is defined as the amount of work, so it is work done for what? To bring a unit positive charge from where to where? From infinity to the point at which we are defining the potential. Okay, so now that we have formally defined the potential, let us see it in terms of equations and mathematics. Let's say a test charge Q is brought from infinity to a point P, right? So somewhere here in infinity it was initially, and then we bring it at P, a charge Q, and we define that W amount of work was to be done to do this task. Okay, now one thing I forgot to mention, that potential is denoted by a V. So the potential at the point P will be equal to the work done per unit charge, but here we are talking about Q charge, so work per unit charge. Okay, so this is my mathematical definition of potential. Conversely, we can write the amount of work required to be done to bring a charge Q to a potential Vp is Q times Vp. So larger is the amount of charge, more will be the work required to be done. Larger the potential of the point, more will the work required to be done. So this is a very important set of formula that we will require to remember by heart. Okay, now let us define what are the units of potential. the units of potential will be basically unit of work upon the unit of charge. So unit of potential is work is defined by joule and charge is defined by coulomb. So it is joule per coulomb, that is the unit of potential, and this joule per coulomb is given a name that is known as volt, defined by capital V. So this is our units for potential, electric potential. Now, how much is 1 volt? 1 volt is when 1 joule work needs to be done to bring 1 coulomb charge from infinity to that point. Then that point is said to be having 1 volt of electric potential. Fine. Now we have already seen what is potential, okay, but a more practical terminology or a more practical concept is of potential difference rather than potential, because it's quite difficult to find the potential of every point because we have to trace it back from infinity to that point. But what potential difference does is that it finds the difference of potential between 2 points, okay, as the name suggests. So let me draw it briefly here. Suppose we have a point here which is A and we have a point here which is B, right? So this point will have a potential of PA, which is calculated similar to this calculation. We bring it from infinity to the point A and take how much work is done per unit charge. That will give me PA, potential at A. Similarly, this point will have potential B defined by PB, let's say. Then potential difference, or PD in short, between B and A is PB minus PA. So the potential difference between B point and A point is PB minus PA. And what does this signify? The potential difference between B and A? This signifies the amount of work that requires to be done to move a unit positive charge from A to B, right? So this gives me work per charge, positive charge, to move it from one point to another point. Therefore, this also will be similar to the case, the formula will be similar to W upon Q, the work per unit charge. And though I have written here PA and PB, I should have ideally written it as, let me rectify it, VA and VB, because potential is defined by a V rather than a P. Okay, so VA minus VB will be work done to move it from the A point to B point upon how much charge is being moved. Okay, now since potential difference is the difference between potentials, therefore its unit is also same. Unit of potential difference is also volt, okay, or joule per coulomb. Fine. So this chapter or this particular discussion, we saw what is current, then we touched upon what is potential, we understood the concept of it and how potential is useful in defining the direction of flow of heat or a ball or current. Then we discussed what is potential at a point. Then finally we discussed what is potential difference, PD. So this gives us a backbone for the further discussion on current electricity and electricity in general. Next class we'll start discussing resistance and the different aspects of it. So till the next class, have a great day. Goodbye. Next class, have a great day. Goodbye.